This is for Year 12 Specialists. It comes out of the TSSM 2011 Exam 2 Question 2 in Multiple Choice about implied domains for composite inverse trigonometric functions. Given that the domains of sine and cos have these restrictions, and these restrictions are the normal restrictions for sine and cos, therefore what's the implied domain of this particular function? Okay, so it's going to go through a few things. It's going to go through 2x first. After it comes out of the 2x, it's going to go in through the 2 inverse cos of x. And after it comes out of it, it's going to go in through a sine of x. Okay, so the things that would normally go into an inverse cosine is -1 to 1. An inverse cosine would look like this. But since it's been multiplied by 2, what would normally come out is 0 to pi, but that would be 0 to 2 pi after it's been multiplied by 2. So that would go up to normally pi, but it's going to be expanded up. Now the problem about that is the things that go in through to sine are minus pi on 2 to pi on 2, and what would come out would be -1 to 1. Now I have a problem. I've got a couple of problems. The biggest that can come out of an inverse cosine is 0. So that's going to have to be a 0, which means that's going to have to be a 0. And for this to be pi on 2, then that's got to be pi on 2, which means that's going to be pi on 4 for that to be a 1. So for 0 to pi on 4 to come out of my cos, because actually I'm multiplying by 2 there, so I'm only going to go up to here. I'm only going to have 0 to pi on 4 as part of the range that comes out of this inverse cosine. So what would be the cos value that gives pi on 4? That's √2 on 2. So my domain has to be √2 on 2 through to 1. It's going to have to be these x values to give a range of 0 to pi on 4, so that when you double it, 0 to pi on 2 will fit into this sign. So 2x has to go from √2 on 2 to 1, which means x will go from √2 on 4 to a half, which gives me B as being the correct answer.